Greetings to our respected lectures and panel judges. We are from HJ3. We'll present to you a video on augmented reality versus virtual reality, some of the finest man-made inventions ever created. AR and VR are two emerging technologies that have the potential to revolutionize the way we interact with the world around us. Both technologies are computer-generated elements to enhance our perception of reality, but in a totally different ways. So, this is our group members, Jonathan, Sabrina, and Anwar. Today, we will talk about what is AR and VR, how do they work, usage of AR and VR in our daily life, and which is better among two of them. First and foremost, what is augmented reality or better known as AR? AR is a technology that overlays digital content such as images, videos, or 3D models onto the real world. Users can still see and interact with their physical surroundings, while digital elements are superimposed onto their view, typically through a device like a smartphone, tablet, or AR headset. We can take the game known as Pokemon Go for example, which allow us to interact with 3D generated live models of Pokemons through our smartphones. On the other hand, virtual reality or VR creates completely computer-generated environment that immerses users in a digital world. Users typically wear a VR headset that covers their field of vision, blocking out the real world, and replacing it with a stimulated one. Some popular brands of VR headsets can be found nowadays are PlayStation VR, Meta Quest 2, and many more.
So, how do AR and VR work? So, first of all, AR devices are equipped with various sensors, including accelerometers, gyroscopes, GPS, and cameras. These sensors help the device understand its position and orientation in the real world. Next, computer vision. The device's camera captures the real world environment, including objects and surfaces. Computer vision algorithms then analyze this visual data to identify key features such as markers or objects that can serve as anchor points for AR content. Third, tracking. AR systems use tracking techniques to keep virtual objects aligned with the real world. This involves continuously monitoring the device's position and orientation in real time. There are several tracking methods, but the two most common are markerless and marker based tracking. The difference is that the latter relies on a recognizable image, whereas the former does not. Finally, content rendering. Once the device knows its position and orientation relative to the real world, it can render digital content such as 3D models, text, animation, or videos on the device's display. This content appears to be integrated into the user's view of the real world. Enough about AR. How does VR work instead? First of all, we are going to talk about the HMD or head mounted display. The core of most VR systems is the head mounted display, which is a specialized headset worn over your eyes. This headset contains two small screens, one for each eye, that displays stereoscopic 3D images. These screens are often OLED or LCD panels with a high refresh rate to reduce motion sickness and improve the sense of presence. Next, stereoscopic vision. To create a sense of depth and immersion, VR displays separate the images for each eye, simulating the way our eyes perceive the world. This stereoscopic effect is essential for creating a convincing 3D environment. The tracking data from sensors and input devices are processed in real time by the VR system. The system continuously updates the position and orientation of your head and hands, ensuring that the virtual world aligns with your movements. Finally, immersive video and display mirroring. In many VR setups, there's an option to mirror the virtual display to an external monitor or screen so that others can see what the user is experiencing. In addition to visual immersion, VR systems often incorporate 3D spatial audio, which means that sounds come from specific directions and distances in the virtual environment. This adds to the overall sense of presence and realism.
Moving on to the next main point, the uses of AR and VR. You'll be surprised by the wide use of this advanced technology other than gaming. The most common use of AR is for gaming, such as for the game Pokemon Go. Next is for education, for example, interactive textbooks. Then we have navigation, for example, AR navigation apps such as Google Maps and Waze. Lastly, for examples, is industrial applications. It is mainly used for maintenance and repair guidance for workers. Next, for VR, they are often used for immersive gaming, training simulations, for example, flight simulators, healthcare, mainly used to train workers, design and architecture, for example, virtual walkthroughs of building designs, and lastly, virtual tours, for example, exploring historical sites. Now for our last point in this presentation, which wins the case? AR experiences can easily integrate with the real-world social context, allowing users to share their AR experiences with others and interact with people in the real world. VR can be more isolating as users are fully immersed in a virtual environment and may not be aware of their physical surroundings. However, some VR applications support multiplayer and social interactions within the virtual world. In conclusion, after all that we presented to you, all the flashy transitions and slides, for whom that takes the cake depends on you actually. Both AR and VR has their own pros and cons, so it depends on each person's taste to determine which is better. Or both can be the winner if you think of it that way.